Okay, so here are the examples that you need to kind of be able to go through for section 11.1 and 11.2 before we do the examples in class. So 11.1, 11.2, areas of parallelograms, triangles, trapezoids, rhombuses, and kites. If you weren't in class, watch the video where I go through the formulas. I went through them much more slowly in class and thoroughly, but get an idea of where those formulas come from. If you were in class and you ever forgot, you can go back to that video. But let's see here. So we found areas, rectangles, and squares. Now we're going to do parallelograms, triangles, and trapezoids and kites. So we're going to do all of them in one section, really, because they all are similar enough that it's good to be able to kind of clump them together. So the first postulate, 11.1, is the area addition postulate. And basically the area of a region is the sum of the areas of its non-overlapping parts. So you can add up if you can cut into parts that don't overlap, add up those parts, you'll get the same as the full area. Um, Area congruence postulate. If two figures are congruent, then they have the same area. So that way you don't have to worry about, hey, if they're the same size, could they have different areas? No, they'll have the same exact area. Here are all the formulas from the book. Area of a parallelogram is base times height. Triangles, 1/2 base times height. Trapezoids, 1/2 height times base 1 plus base 2. And then rhombi and kites, or rhombuses and kites, however you want to say it, 1/2 diagonal 1 times diagonal 2. So here's our first example. Find the perimeter and area of parallelogram RSTU. Okay, so here we go. First example. Find the perimeter and area. The area, sorry, the perimeter will be pretty easy to find because this is 32, and since it's a parallelogram, that means this also has to be 32. So these are both 32. Okay, and this guy here, since he's 20, this is also 20. So perimeter is 32 times 2 plus 20 times 2 for the two sides. So 64 plus 40, perimeter is 104 inches. Okay. Now area though, they gave us that this is 12 inches for a reason. That's because it's only 12 from here to here. I'm going to have to find the height by doing the Pythagorean theorem. Or you may remember your Pythagorean triples. This is 3 times 4. This is 5 times 4. So that's 74 times 4, which is 16. Okay. So that's the height. So area for that will be base times height. Area is then base, which is this guy here, the 32 all the way across. The height is 16. So that's going to be 256 times 2, which is 512. But just to make sure I'm doing that mental math correctly, get my calculator out. 32 times 16, 512, yeah, 512 square inches. Okay. And one thing I got to make sure I covered, that I know I covered it in class, but I might not have covered it in the other video, is that base and height are always perpendicular. So that's how you know which one you got. Okay, so perimeter is 104 inches, area is 512 inches squared. Okay, so another one. Again, find the area this time, not perimeter, just area. Okay, so, yeah. All right, now looking at this one, we have to remember what kind of figure we have here. And we have a parallelogram. So area equals base times height. The base is obviously 12, so that's not a big deal. The trouble is the height. And you might say to yourself, well, how in the world am I going to find that? Well, it's actually quite easy to find because the fact that this is 45 degrees. Here's a right angle, meaning this also has to be 45, meaning this is a 45, 45, 90. Now, if you're like, how do I know this what the 90 is? It's over here because the opposite sides are congruent. So 9 and 9. So the rule for a 45, 45, 90 was, oh gosh, sorry, let's draw this a little more nicely, is that this is a root 2 and this is a and this is a. So 9 equals a root 2. I want just a. So divide by root 2. That's 9 over root 2, which when I rationalize it is 9 root 2 over 2. Okay. So that is the actual height. Okay. Which actually kind of makes this nice because the 2 and the 12 cancel to be 6 and 1. So 6 times 9 root 2 gives us 54 root 2. Are there units here? Nope. So units squared. If you don't like that as an answer, because you like a decimal answer, now you just get your calculator out. 54 times the square root of 2. Oops, I don't need that extra button there, do I? And it's 76.4, the nearest tenth. There we go. All right. Next example here, I think it's a triangle one. Yeah. So you need to buy enough boards to make the frame of a triangular sandbox shown and enough sand to fill it. If one board is 3 feet long and one bag fills 9 square feet of sandbox, how many boards, how many bags do you need to buy? Okay, so this is really a two-part question. One for the boards, one for the sand, one for the bags. Okay. All right, the board should be hopefully relatively easy. Because really you've got, that's not what I meant to hit. Because it's a distance thing. So one board is 3 feet long. So we look at our drawing here. We're looking for perimeter. Perimeter is all three of those added together. So perimeter equals 16 plus 12 plus 7.5. So 28 plus 7.5 is 35.5 feet. That's what we're going to assume. So to figure out how many boards we want, we're going to take 35.5 divided by 3, which is approximately 12. So we need 12 boards. Yeah, because one board is 3 feet long. Okay. Now, for area, area is 1/2 base times height. Well, our base is the 12 here, and the height is the 9 because it's perpendicular to the side that contains it. So it'd be 1/2 12 times 9, so 6 times 9, which is 54 square feet. Okay. Now the thing says we need one bag of sand to fill 9 square feet of sandbox. So that means in 54 over 9, which is 6 bags. All right, so now we're going to start jumping into our other shapes, the trapezoids and so forth. So find the area of the steel used to make the size of the razor blade, the side, of the razor blade shown. All right. Okay, look at this razor blade. We have to realize that this is a trapezoid. One, because it looks like it. We don't really have anything telling us this is parallel, but we'll assume it is. So area of a trapezoid is 1/2 height times base 1 plus base 2. Well, here's base 1. Here's base 2 because the two bases are the parallel sides. And the height is the distance between them. So area equals 1/2 height, which is 1, times base 1 plus base 2, which is 3 plus 2.5. That's going to be then 1/2 of 5.5, which is 2.75 square centimeters. Okay. All right, next. Looking at Miguel and his deck. So Miguel designed a deck shaped like the trapezoid shown below. Find the area of the deck. Now the tricky thing about this one is that we have the height, or at least we have to assume we have the height. We're going to assume this is a right angle. Okay, and if this were a test or a quiz and you weren't sure, I would tell you, yeah, this is a right angle here, so don't worry about it. Although otherwise I'd really have it drawn in there. So here's base 1. There's base 2, because those are the two parallel sides. Obviously 4 is the height. The tricky part is, I don't know base 2's length. That's the real trick to this problem, is figuring out the length of base 2. Well, what you have to do is be a little savvy and realize that if you drew another perpendicular line straight down here, okay, that this would still be 4 as well. And if I could figure out this length right here, then I would know how much to take away, and that these two guys here would be congruent. So our real trick to this is that, oh, this is 4, this is 5, it's going to be a right angle as well. And you could do the Pythagorean theorem to solve for this, or hopefully you catch that this is a 3, 4, 5, because we already have the 4 and 5. So that means this is 3, meaning this guy here is only 6, because 3 and 6 together is going to make the whole 9. And then that means base 2 has to be 6 as well. And now we're ready to find our area. Area is going to equal 1/2 the height times base 1 plus base 2. Okay, so it'll fit in there. Good. Okay, so area equals 1/2 of 4 times base 1, which is 9, plus base 2, which was 6. Okay, so 1/2 of 4 is 2. 6 plus 9 is 15, which is 30 square feet. There we go. Okay, next example, just moving right along. Find the area of the kite. This one should be pretty quick and easy. Okay, so here we go, looking at our kite. Formula for area of a kite. Area equals 1/2 diagonal 1 times diagonal 2. And guess what we have? Diagonal 1, diagonal 2. Okay, or you could switch those, it doesn't really matter. Either way, it's 1/2, 7 times 12. Easy to do is do half of 12, make it 6. So 7 times 6 is 42 square feet. Okay. Next example, not much more work. Oops, it's the same one. Sorry. There we go. Find the area of the rhombus. Now they try to make you work a little bit more on this one because they don't give you they don't flat out give you the whole length of the diagonals, but they don't make you work that hard because this is 9, they mark this as congruent. Hey, this is also 9. This is 7, they mark this as also congruent. Oh, so that's 7. So the whole diagonal here is 14. This diagonal is 9 plus 9, so 18. So the area then is 1/2 d1 times d2, 1/2 diagonal 1, which is 14, diagonal 2, which is 18, and that gives us then 14 times 9, which is 126 inches squared. There's the area of that rhombus. Okay. Okay, last example then for this section. Trapezoid QRST has an area of 210 square yards. Find the height of QRST. So we're solving for part of it, knowing another part. Alright, so we look at this, our formula for area of a trapezoid. 1/2 height times base 1 plus base 2. Alright, we'll just call this guy base 1, this guy will be base 2, because again, they're the parallel sides. So area equals 1/2 height times base 1 plus base 2, which is 50 plus 20. And then we know the area is actually 210. Okay. Now, these together are actually 70. And 1/2 of 70 is a nice number, so I can just multiply those together. Otherwise, I could double both sides and get rid of the 1/2, make this 420. But I'm going to do 35h equals 210. So then I'm going to divide both sides by 35. Okay. And then we'll take 210 divided by 35, which I think is 6, but just to make sure I'm not making that up. Yeah, 6. So 6 equals h. So 6 yards equals h because our units are square yards. And there we go.